says f of x is equal to p of x divided by q of x. P and x and qx are polynomial functions. So remember, a polynomial are going to look something like this. So I'm just going to make up an example. X plus 3, x squared minus x minus 6. Something like that, okay? That would just be an example of a rational function, okay? The top and the bottom are polynomials. And it says q of x is not equal to 0. So remember, q of x is the denominator, and in a fraction, we can never divide by 0, right? We can't do that. We can't divide by 0. It's not a good thing to do. It's like saying bad words in church. You don't want to do it. Okay, so now the first thing we're going to talk about are these things called asymptotes. And it says to find the asymptotes of a rational function defined by rational expression in lowest terms, use the following procedures. So it says, number one, to find any vertical asymptotes, or find any vertical asymptotes by setting the denominator equal to 0 and solving for x. If a is 0, the denominator, then the vertical line x equals a is a vertical asymptote. Okay, so if you notice here I said it's a vertical line, because anytime I have a graph like this, x is equal to a, wherever that is, that's always going to be a vertical line. Okay, and that's what we call it, a vertical asymptote. So how do we find that? We take the denominator, which we're calling q of x, and we're setting it equal to 0. Okay, and then we have something called horizontal asymptotes. It says if the numerator has a lesser degree than the denominator. So let me stop right there. What do we mean by that? The degree of the top is going to be smaller than the degree of the bottom. So if this is x minus 5, this could be something like x squared minus, say, 9, something like that. So if the degree here is smaller than this one, it doesn't have to be just one smaller. This could have been x to the 12th minus 9. This one here is still smaller, right? That power. Then our horizontal asymptote is always going to be y equals 0. And then what happens if the degrees are the same? So let me make this up. Suppose I have something like, 3x minus 5 over 2x minus 11. So notice the degrees are the same. They're both of degree 1. Or they could be degrees 4. Okay, doesn't really matter. As long as the degrees are the same, then what we're going to say is the horizontal asymptote is going to be this horizontal line, y equals 3 over 2. It'll be the fraction of those coefficients right there. Okay, so let's see if we can't figure out how to do these particular problems here. So it says for each rational function, determine any horizontal and vertical asymptotes. Okay, so the VAs, the vertical asymptotes, we're going to find those by setting the denominator equal to 0. So I'm going to take x plus 1, it's the denominator, I'm going to set it equal to 0. We're going to get x equals negative 1. So my vertical asymptote is the line x equals negative 1. Okay. Then the horizontal asymptote. Okay. Horizontal asymptote. We're going to look at the degree of the top, which is 1. We're going to look at the degree of the bottom, which is also 1. They're the same. So the horizontal asymptote, when they're the same, is going to be the fraction y equals the fraction of those leading coefficients. 1 over 1, which is the same thing as 1. Okay? So my horizontal asymptote is just the line y equals 1, and my vertical asymptote is the line x equals negative 1. Okay? Let me do the same thing here. So let's see if we can find our vertical asymptote. Remember, to find the vertical asymptote, I'm going to take the denominator, and I'm going to set it equal to 0. So 2x equals 6. So when we divide both sides by 2, I'm coming up with x equals 3. There's my vertical asymptote. Okay. Now let's find our horizontal asymptote. The degree of the top is 1. The degree of the bottom is also 1. We're going to take the fraction of the leading coefficients. 4 over 2 is the same thing as 2. So we found again our vertical asymptote and our horizontal asymptote. Okay. All right. Let's do the same thing for this one here. We're going to find our vertical asymptote. We're going to set the denominator equal to 0. Move that 5 over. Remember, to get rid of that square, I'm going to take the square root. Don't forget your plus and minus. So notice we have two vertical asymptotes. One of them is x equals the square root of 5, and one equals the negative square root of 5. Okay? One is positive, one's negative. Now, let's find our horizontal asymptote. Okay? The degree of the top is 0. Why? Because there's no x's. The degree of the bottom is 2. Anytime the degree of the top is smaller than the degree of the bottom, the horizontal asymptote is always going to be y equals 0. Okay? Y equals 0. Alrighty? So I'm going to keep scrolling down. And we have a couple of pictures here. And the first question down here at the bottom says, which choices have a domain of negative infinity to 3 and then from 3 to infinity? So first thing, let's remind ourselves, what does the domain refer to? Does the domain refer to the x values or the y values? And I hope you said that the domain refers to the x values, because that would be the correct choice. Not the y values, but the x's, okay? So when we're talking about the domain means what kind of numbers can I plug in for x, okay? What kind of numbers can I plug in for x? So the way this domain here is written, we can plug in any number except for the number 3. So if I were to look at my picture, they all have 3s on them. I see a 3 here, a 3 here, a 3 here, and a 3 here, okay? But what we want to figure out is which ones have the domain from negative infinity to 3 and then from 3 to infinity. That means that the number we're not including is x is equal to 3. Okay? That means that that number 3, guys, is what we would call our vertical asymptote. So I like this problem because it shows me the pictures so I can get an idea of what a vertical asymptote really is. A vertical asymptote is going to be a vertical line, a line going up and down, where the graph gets super close to it, but it never actually touches. Okay? So I want you to notice here. Here's a vertical line at x equals 3. The graph gets really close to it, but it doesn't touch it. So far I would say, well, look, A seems to be one of my choices. Okay? Here's another one. Look, here's a vertical line at x equals 3. The graph gets really, really close to it, but it doesn't touch it. So B is also a choice. Okay? And then when I look at C, look, here's another vertical line. The graph gets really, really close to it, but doesn't touch it. Okay? Now, if you look at this one here, even though there's that open circle, there's no vertical line, okay? It has to be a vertical line. So far for the first one, my choices would be A, B, and C, okay? Now, look at the next one. Down here it says, which choices have a range from negative infinity to 0 and then from 0 to infinity? That means that x equals 0 is going to be my vertical asymptote. So we're going to have a vertical line where the graph is going to get really, really close to it, but it won't touch it. So you look right here, here's my vertical line, x equals 0. The graph gets really, really close to it, but it never touches it. So this one here would be D. And 3.5, guys, pretty short section. That's all of it right there.